Thanks, Sivia, and hi, everybody. We appreciate you spending a little bit of time today learning about orphaned cloud resources and the security risk that they pose. You should see a poll question pop on your screen. Before we get started, it would be great to understand a little bit more about your confidence in being able to identify problematic orphaned resources in your environment, your ability to gain visibility over your environment. We are super excited today to have Dave Williams join us to share a number of tips he uses as a cloud architect at New Light Technologies to help them keep their customer cloud accounts free and clear of orphaned resources and the misconfiguration risk that they pose. And we also have Josh Stella, CTO at Fugue here, to kind of set up the problem and talk about how orphaned resources happen and why they pose a significant security risk. One of the cool things about dealing with orphaned resource issues is this is one of those cases where security actually contributes positively to the bottom line, which is kind of a cool trend we're seeing in cloud security here at Fugue and with our customers. So we'll keep that going. I will be back a little later to facilitate your questions, so please do get those questions in at any point during the webinar using that Q&A box. And with that, I will throw it over to you, Josh. Take it away.
Thank you, Drew. Thank you, Sivia. And thank you, Dave, for joining us today. As Drew said, I'm going to go through a few slides to kind of set up the problem space, but Dave is really going to walk you through a lot of great real-world examples of how to solve this. So, hey, Dave, could you go to the next slide? So what we're going to go through today is an overview of cloud misconfiguration risk. The reason we're starting there is because any resources you have in cloud are potential attack vectors, and the orphaned ones are much more likely to be misconfigured because they're kind of out of sight, out of mind. So first we'll talk about the risk of cloud misconfiguration, and then we'll talk about orphaned resources, why they're pervasive, why they're dangerous, why they're a challenge to manage. And then Dave's going to show you a bunch of great ways to identify and eliminate orphaned resources as appropriate, and some Q&A. Let's go to the next slide. Okay, so cloud misconfiguration is a major security risk. If you read the headlines for these major cloud breaches, they're almost always due to misconfiguration. Neil McDonald at Gartner, nearly all successful attacks on cloud services are the result of misconfiguration. We believe that's true. We see it every day. Over on the right is one of the data points from a survey we did last year of 300 organizations operating at scale on cloud. And 93% of those organizations were concerned for a major security breach due to misconfiguration. So if you're in the 7% that aren't, you should probably be in the 93%. We see this all the time. Let's go to the next slide. Okay, so what are the resource types that can yield a lot of damage due to misconfiguration? Number one response from our survey respondents was identity and access management. And you may be thinking of identity and access management in kind of the old school ways where these were just kind of user roles for human users. But a lot of times in cloud, these roles are used actually for connection between resources in the cloud environment. So they're actually much more dangerous than in the data center days. Number two, security group rules. That's like firewall rules. Definitely a big thing to be concerned with. Object storage access policies next, right? We always read about, or we often read about S3 buckets getting breached. Well, a lot of times that's due to bad IAM and security groups as well. So these are related. And then finally, encryption in transit disabled, obviously bad for lots of reasons. Let's go to the next slide. So hacker strategy has evolved in recent years. It's constantly evolving, right? It never holds still. But one major change we've seen at Fugue, and this says kind of before cloud on the left and cloud on the right. I'm not sure it's totally driven by cloud, but it certainly has coincided with it. In the old days, what a lot of bad guys were doing was identifying target organizations and then looking for vulnerabilities to exploit. That does still happen, right? There are spear phishing attacks against particular targets, etc. But more and more often what we're seeing, and if you read the news carefully, you'll see a lot of the big breaches you hear about are done in a new way. And that new way is bad guys scanning all of the internet for known misconfigurations. So instead of targeting an organization and then trying to find things that are exploitable, the bad guys are collecting through automation targets that are exploitable and then prioritizing which of them to exploit, often in minutes of those misconfigurations being visible via public IP. So the takeaway here is, even if you're not the highest profile organization, you are vulnerable, one. And two, you only have minutes or hours to fix things, not days, weeks, months, or years. And as we get into talking more about orphan resources, they're often weeks, months old. So bad actors are using automation to find and exploit these cloud misconfigurations. Let's go to the next slide, please.
Hey, Josh, real quick, what is the anecdote that you've told me about? This is Dave Williams, by the way, about how long it takes to find something once it's kind of internet exposed?
Oh, yeah, thank you. I have a friend and colleague, not an employee here at Fugue, and he and I were talking, and he had seen some research and participated in that research that showed that any given public IP address is going to have been scanned for misconfiguration and vulnerabilities within approximately 7 minutes. That doesn't mean one entity scans them all every 7 minutes, but there are lots of bad guys out there doing this, and some of them, the sophisticated ones, do form networks. So exposed attack surface through misconfiguration is a very real problem. Thanks, Dave. So what are orphan cloud resources? They're resources in the cloud, things like EC2 instances or VPC networks that are kind of idle, hopefully, but particularly that you're not really aware of. So an orphaned resource is something that got built somewhere along the way in your cloud journey that is kind of off the radar. And when I say hopefully it's not in use, in many cases it's Bitcoin mining for someone who's not you. So this is widely recognized as a cost problem, although not every orphan resource incurs costs if it's idling, right? A security group that is not in use isn't going to have an hourly budget attached to it in your AWS bill. But a lot of them do. A lot of them do have costs. So common examples, EC2 instances, EBS volumes, VPCs and security groups, AMIs. Also S3 buckets. One of the things we do at Fugue, and you'll see a little bit of this later, is we can visualize whole cloud environments. Almost every new customer during onboarding, when they do this automated visualization, they'll find something. Like last week I was in a meeting and we brought up the visualization and someone said, hey, that VPC network, what is that? And they looked at it and they realized it was something an intern had built a year ago and never shut down. And it also had S3 volumes attached to it. And these things exist, these orphaned resources, in practically every enterprise cloud environment. The reason for that is it's really easy to build lots of stuff on cloud, and it's really easy for that to kind of get out of control, and for those thousands or tens of thousands or hundreds of thousands of resources hiding in there are often some of these orphaned or resources. In my experience, it's not uncommon for even 20% or more of cloud infrastructure to be in kind of an unknown state. Are we even using this? And that connotes a kind of orphaned status. Let's go to the next slide. So why does this happen? What are the challenges in managing cloud resources in general and also finding orphans? One is a lack of full visibility into cloud environments. You might be thinking, well, hey, there's lots of reports that you can pull from cloud provider tools and from third-party tools that will list all your stuff, and that's true, but that doesn't really, that's not how humans work, right? We don't think in terms of spreadsheets, and it can be really hard to contextualize these things. So What we like to do at Fugue is to provide this information visually, because humans are really good at identifying those things. So full visibility doesn't just mean the thing is on a list somewhere. It means it's known what it's doing. It is a known state of what it's doing, who owns it, things like that. Dave's going to get into this more, but a lot of times this is due to insufficient tagging and tagging conventions, or also naming conventions, and insufficient auditing and control capabilities. Let's jump to the next one. Right, so why do these happen? Very often we've seen leftover maintenance infrastructure. Somebody has to stand up some stuff to do work in the cloud environment. Maybe they're using infrastructure as code most of the time, but when a trouble ticket comes in and things need to be debugged, they might fall back to the console, not tag things, and forget they're out there. Poor management practices that fail to track and cull resources, things like EBS volumes, AMIs, EC2 instances. If you're not fully leveraging infrastructure as code, or honestly, even if you are, it's pretty easy to lose track of these. Lack of tags and tag enforcement policies, we've mentioned, and dev environment leftovers. Dev environments are attack surface. There are lots of examples of how dev environments have been used by bad guys in really sophisticated cases to do things like code injection. But even learning the topology of a system by exploring a dev environment helps them break into production. So these things need security too. And the fundamental cause of all this is, human beings are just really bad at managing complexity at scale. We're good at abstracting, we're good at intuition, we're good at being creative. We're really bad at remembering very long lists of things. But the good news is we have these wonderful devices called computers and programming that are awesome at managing complexity at scale. And because cloud is made of APIs, we can use the tools of software engineering to do that. Let's go to the next slide. So why do these things form a security risk? Well, going back to some of the earlier examples I gave of attacks where people are scanning for things that have vulnerabilities. Well, what's the prevention to that, right, is yourself scanning and catching vulnerabilities prior to bad guys doing it. Well, if something's orphaned, you're not going to be looking at it with your tools. You're not going to be assessing it. You're not going to be validating them for compliance. If it's running an operating system like an EC2 instance, they're probably not going to be patched. And therefore, as new vulnerabilities are found in whatever libraries and applications you're using, they're not getting patched. Those show up on the radar when the bad guys scan that IP address. They're not being cycled out via immutable infrastructure practices. So what we mean by immutable infrastructure is instead of maintaining things, you replace them. So instead of patching a server, you stand up a new one and kill the old one. A lot more of that with things like containers these days. But a lot of folks have infrastructure that either doesn't work that way and can't, or they haven't configured to work that way and should. But immutable infrastructure patterns do really help with this. Netflix is famous for their chaos engineering and full automation. That's really what to aim for. And then finally, attacks that are exploiting these orphan resources, often the attacks themselves are likely to go unnoticed because you're not paying much attention to the resources, right? They're orphaned, you're not looking for those. And so that creates the kind of scenario where, for example, in some recent news, there was a big breach that went unnoticed for over 120 days, I think almost 130. So these are the big reasons why you should think of every orphaned resource as attack surface, and it's more vulnerable than the things you're managing. So Dave, why don't I turn it over to you to get to all the good stuff?
Thanks, Josh. Thanks, Sivia and Drew, and it's really tickled to be part of this. I think, thinking about what Josh has kind of set up, we're going to go into some specific things you can do today to hopefully, find and remediate these orphans. But I think the best thing to come out of this chat is just awareness of this topic. There's no magic bullet. Other than removing your cloud environment, which is not really feasible for most folks, you're going to have these sort of things that exist. I think committing to some sort of recurring investigation of what you have is really the most important thing. But we'll go into some specific things, and we'll share these out. There's some links to some repos, there's some scripts, and some tips. So hopefully this is stuff you can use today. I know when we take over a new customer's cloud environment, it's very common for us to find 20, 30, 40% stuff that's either over provisioned or orphaned that we can remove, and it costs them less and also reduces their threat surface. So let's jump right in. Well, the first thing is, if you're like me and have been working in AWS and Azure and other environments, you've probably had to document things and probably spent hours in tools like Visio and these other drawing tools, and probably really limited the fact that it's manual and updating things is tough. I've tried ways of automating things. But the best thing I've come across so far that is visually appealing and readable, accurate, and dynamic is a part of the Fugue platform called their visualizer. So let's jump over to that and take a look at it. So this is the Fugue front end. I'm in an AWS sandbox account for my company. This is the front end. I just wanted to show kind of what it looks like when you come in. This up here where my cursor is called visualizer. So when I click on it, it renders based upon the last scan of my environment, the high-level resources. And it's sort of scale-based if I have a GIS background. So as I zoom in, the symbology changes, the amount of information changes. The color coding also means that certain things are in violation of different policies that we've configured. But this is a way, and we share this with our clients, of drawing and visualizing what we have out there. So we can quickly assess, hey, I've got 3 VPCs. I can drill down into this one here with this naming convention. I can expand it. I can see the EC2s I have. I can see that they're tied to certain security groups based upon this lettering. So from a quick summary view of what do I have, what's out there, discovery, and as Josh is saying, so I started my career in mapping. Everyone says they're more visual, or I'm a visual person. You'd probably say that. People like graphs and charts and maps over spreadsheets. So this is one way of quickly assessing what you've got. Another part of the Fugue platform is compliance by resource type. So I've already activated this to make the alt tabbing in here a little bit easier. But what this lets me do is quickly get a summary of what resources I have deployed. And in this case, I am comparing my resources. What I've done is, what the Fugue platform, one of the things it does is it lets me compare what I have deployed to certain security control sets, compliance sets, NIST 853, very heavy in FISMA and FedRAMP. CIS, SOC 2, there's GDPR, HIPAA, and some other, I think there's a couple more. But what this lets me do is quickly get a visual cue of what do I have deployed, and probably as extremely important is what is not in compliant to whatever control set I have. So a quick and easy way to find out what I have. Let's go back to the slides. Okay, so the next thing we're going to talk about are some of the native services. We primarily work across AWS and Azure. That's kind of where the market is. We also work in some of the other platforms, Alibaba or Google. But there's a variety of native services that can help you summarize and ascertain what you have. We'll take a look at what's called AWS Trusted Advisor. If you haven't used this in AWS, it's probably worth checking out. All right, so here's, let me give me a second here to, okay, good. I have to log back in. So if you search for it under the AWS services primary search, you get to this Trusted Advisor dashboard. It's a variety of recommendations on performance, security. Hopefully my internet connection is not unstable. I assume you guys can hear me okay. But what we quickly get a view of, and I've clicked on the security drill down, is some recommendations about security configurations. And this helps me quickly see, for example, this one. This is security groups, specific ports are unrestricted. This environment that we have running is a very, we purposefully seed it with some bad configs. But if I expand this, you see I've got a variety of security groups with 3389, which is the remote desktop or RDP port, SSH port. So this is a tool if you're using AWS, which you likely are, and you're not using Trusted Advisor, I'd recommend checking it out. All right, the next one is a script that I pulled. It's basically deployment of this script here. It is to find. Oh, and I need to let me make this a little bit bigger. I'm just going to run with it. Sorry, the text is kind of small, everybody. I meant to make this bigger before starting. What this script is going to do is find snapshots that were once used to create AMIs. That are no longer attached to AMI. So this is, you're paying for storage that you basically, you're very likely not using and not ever going to use. So with this script, let's see here. Give me 1 second. And I do apologize for the text size. Like I said, we'll send this out so you can get a link to the repo. Let's see here. So what this does, it's going to find AMIs that snapshot's not bound to them, and it's actually gonna give you the commands, the CLI commands to remove them. All right, and then let's move to the second one. The second shell example we're going to show is to find unused security groups. So, where's the threat here? Well, the threat is, I think it's just sort of good hygiene to keep your security groups clean and not have them out there that aren't being used. But I've had scenarios where people have taken an existing security group and apply it to a new deployment, and especially if that security group has a vulnerability or an open configuration, that's something we don't want to support. So we're going to run this next script and quickly find our security groups. All right. There you go. And from here, I can write the CLI commands to clean that up. I can jump into the console and remove them. All right, let's go to the next slide. All right, so the first thing we're going to see, we're going to look, and here on, I think is going to be through a browser. So we're going to find unattached EBS volumes. And what EBS volumes are basically disks. And by the way, we're showing kind of AWS heavy. This works the same in Azure. A similar sort of approach for finding and cleaning up things. We're going to find EBS volumes that are no longer attached to virtual machines. These are disks that very likely you don't need, are paying for, potentially have content on them that you don't want exposed. So let's find a way to quickly find them and remove them. All right, so back to the console. If you log into, probably everyone on the call has been in AWS. If you go into the EC2 services page, under EBS or Elastic Block Storage on the left, there are volumes. Well, you can sort by the state. That shows you what's available. Available means they're not attached. In use means they are. So this is one way of quickly assessing and summarizing what disks you have or what EBS volumes you have that you probably, or at least you should explore to determine if you actually need them anymore. All right, next thing. Security groups with RDP or SSH ports open to the internet. Well, we can do that. We saw that with Trusted Advisor. So using the Trusted Advisor, it'll pick up and say, hey, you shouldn't have SSH open to the broader internet. The Fugue platform also helps us with this. So let's, sorry, I've got the Zoom. I don't think you can see it, but I'm getting my tabs blocked by the Zoom thing. I'm going to click on another one. And there we go. So in Fugue, I can look at my I can look at as we showed before, the compliance by resource type. I can choose security groups, and then what it'll tell me is based upon the control sets that I have enabled. Here, this is NIST 800. Here, this is SOC. It's going to say you shouldn't have, in this case, 000/0 40/0, which is internet exposed, port 80 in this case, right? And the same will work for other common ports that SSH and RDP things that are going to open and expose you to the internet. So it's a quick way of getting a feel for what security groups or software-based firewalls, both in Azure, AWS, other environments that are exposing you and increasing your threat surface. Well, okay, so the next thing is one scenario that we've run into is there's a VM or an EC2 running, and we don't know who it belongs to. There's no tags on it. One trick that I found that saved me more than once is looking at the key name, the key pair name. That, interestingly, usually means something to someone if there's a lack of tags or names. But a quick way to find out who may have last accessed it, because logged onto it, because you may not, that machine may just be running out there, idle, unused, definitely not being patched. In Linux, and people that know, familiar with Linux, the last command will tell you the last login. In Windows, you can do it through some configuration of Event Viewer. Takes a little more work, but it's a quick tip for finding out what the last few logons were. Maybe that was a year ago. That's going to give you ammunition to make a recommendation that maybe this machine doesn't need it. All right, next one is activity on S3 buckets. I think S3, S3 has been in the news over the last couple of years for different exploits. They really fall under the misconfiguration banner. Public access, exposing content to the public when you don't mean it to be. Well, it's really easy to create and provision these storage environments, but you probably have several out there. You don't know if they're being used. A quick way to find out if anyone's actually using them is through the usage reports that are part of the billing services in AWS. So let's go over to that. Yeah, go ahead.
Dave, one of my favorite podcasters, Corey Quinn, Screaming in the Cloud is the podcast. He talks a lot about AWS issues, and he said the only place where everything you're running in AWS is by looking at the bill. And I think that's often the case.
Yeah, that's a great point. I think I think it's common for engineer folks to not have access to the billing environment always, especially in highly controlled environments. But if you do, look at the invoice, look at the monthly invoice. It'll tell you exactly what you're paying for, and it's quite likely you'll find a percentage of services and resources on there that you go, what is that? Do I need that? That can really be a lighthouse to kind of guide you in and where your research ought to be. And actually you find that under the billing services. But going back to the usage report. So here in the billing services in AWS, there's a cost and usage report environment. And what this provides you is very detailed information on the different services that you are using and how much access, how much usage they're getting. So if I click on that, I can choose here, so you have lots of fidelity on what the different services are. S3 being the simple storage service. I can download a CSV, and then once you have that, now it's going to be very granular. And I pulled this into Excel. I've enabled data filtering, and here, so these are the different S3 bucket names in this account, and you see they all are appended with that account name. Here, I'm just going to enable one. We used to use this one for the remote state for Terraform. So I'm filtering by that, and now I've got these various usage types and operations. This isn't a straightforward report on if this is being used or not. You're going to find all accounts, there's usage across the different operations, the reads and lists and so forth. But what this will tell you, it'll start to give you a feel for what does an S3 bucket that's being commonly used by humans, what do these numbers look like, these usage values, and they change. One is byte hours, there's data usage, data out, and transfer. If you compare a few, and especially ones that you suspect are low usage, and compare that to an S3 environment, an S3 bucket that is being used, these numbers will start to jump out, and it'll give you an idea that, hey, most of this stuff is bots. These are AWS reporting tools and services running, and it'll help you track down and start to get confidence that this environment is probably not going to be used. This might be a good candidate to maybe just sort of quiesce access, find out if anyone screams about that. That's sometimes that's the only way we can actually determine if resources are being used, is to stop them or to turn them off and find out who may give you a phone call or email. All right, so there's one tip, and this usage environment or usage report, you can do it for all the services. So if you want to find out who's using what at very fine-grained detail, that's the way to do it. I'm not going to jump back to the slides, but the next thing that I want to talk about, this is one I think most people will probably have experienced, but I think it's in my experience, It's very easy to create users, right? You have a new project, you have new folks onboarding. Most companies and clients I've worked with are struggle a little more with cleanup. Well, within the standard user IAM console, and this is our this is a sandbox account, I can see that a lot of these users have never logged in, or I can see when their last login was. Well, use this to maybe clean these users out. I mean, if folks aren't using it, do they really need to be in there? Those are keys and credentials that can be potentially exploited, and so let's reduce your threat area. All right. Okay, so we've talked a bit about how do you find what's out there, how do you clean it up. Let's talk a little bit about how do we prevent this in the future. The first thing I've got on here are resource groups. If you're an Azure user, you know this term very well. Azure requires use of resource groups. What they are, and they're a little bit different in AWS than Azure, but fundamentally these are logical containers of resources. In Azure, when you deploy a stack or one or many services, you can actually remove them in their entirety by just removing the resource group. In AWS, they're really tag or CloudFormation stack-based groupings. It works a little differently, but what I definitely recommend is an exploration of resource groups, especially in AWS if you haven't used them. They can provide a shot in the arm or provide value for billing, for just tag management, for resource management, and if you're doing things like tag-based IAM rules, for your RBAC, for your role-based control. So check them out if you haven't used them. They're probably only going to help. All right, the next topic, and this is one that I think everyone has experience and opinions and kind of strong feelings about, are naming and tagging. And for the sake of this chat, names are basically a tag. They're kind of a special tag, but under the hood, they're fundamentally a tag, I believe, across both environments. So I'm going to kind of refer to them. I'm going to refer to names as another tag. I can't advocate strongly enough for the use and the required use of tags. If you have opened a console, the AWS console, the web page or Azure portal, and you're looking at resources, no name, no tags, you know how frustrating it is to go, I have no idea what this thing is for, and you start on some sort of sleuthing and detective work to try and figure out what's going on. Well, the 4 tags that I think work across every environment I've worked in, and we require our name, which is the name of the resource. And what I'd recommend here is, and I've worked with different customers, we've come up with really complex sort of naming standards and nomenclature. Whatever your standard is, I'd recommend that it has some human readability and value to it. I've worked in environments where it was a GUID, like a long string of text, or a long string with no real value other than being unique. I've worked in environments where it was a bunch of sort of very sort of unclear terms about what these things mean. Like a 3 letters hyphen 3 letters hyphen 3 letters, where it had value, but you had to decrypt it, basically. Whatever your standard is, just use one and have it have some value so that people that are coming into these environments, because I'm working across multiple accounts. I can't remember one thing from the next. I've had to learn as I got older to write everything down. I want a model that allows me to figure things out quickly and at least let me know where I need to start going to figure out who uses it, who do I need to contact, to make sure that we can do things, maintenance and patching or just documentation. The 3 tags that I feel strongly about and we use are some sort of POC tag, basically someone to contact, right? This can be a person, an email, a phone number. The more the better. It can be a distro group. But when I'm looking at a resource, give me someone to contact when I have questions. Project, right? And this, what is this basically supporting? What kind of stack is it? It can be a technology, it could be a project based, it could be a customer. Describe something about what it's doing. And then one that definitely have strong feelings about is some sort of deployment date or some sort of timing date based stamp that's part of the tagging scheme in a format like ANSI. And there's a variety of these that is standard, known, and enforceable, so that I can do tag-based queries and tag-based automation and tag-based scripting. In other words, hey, let's query for all the EC2s that have been out there and deployed more than 2 years or more than 6 months. let's review those, or is some, and so enforcement of some sort of date standard, so you can be confident that that people are adhering to it. This has saved me, and this is extremely valuable. Other tags that have helped are a deployment model. So we use Terraform a lot. I put that in there because in some cases when there's a bad deployment, I have to go back in and manually clean things up. So knowing whether it was manually deployed or Terraform deployed or CloudFormation deployed has been helpful. Sometimes tier, for example, is this a prod environment? Is this non-prod? Often, and more lately, that's sort of covered by what account or subscription you're in. But these are the 4 tags, name including, that I really have strong feelings with. Okay, so this is great. Probably most people are nodding their head. Probably most people have worked through this. The real rub is, how do you enforce it? And this is where we're doing some interesting work that we'll hopefully have a chance to do a webinar like this on later. But what we've been working on is a deployment CI pipeline, integrated pipeline, that any deployments that we have, and these have to be scripted, right? So we're talking about, and we'll talk about them in the next slide, why that's important. But since we are Terraform users, we'll talk, when we write our Terraform deployments, our Terraform scripts, we, prior to deploying them, we run them through a policy checker. There's so HashiCorp, which owns and Terraform is one of their products. They also have a product called Sentinel, which does this. We're not using that. We're using an open source tool, and it's called Open Policy Agent. And what it allows us to do is to write policies, and a policy can be written in any way about anything. So, for example, in this model, we have policies that say, if a resource can have tags, it must have these 4 tags. And it's written in, and they have a language called Rego, which is it's just it's converted to that language. And what we do is we pipe the Terraform script to that, and OPA checks our script. It converts it to JSON. We convert it to JSON. It interprets it, and if it passes, right, then the deployment occurs. In this pipeline, we also are integrated with Fugue, so that we use Fugue sort of post deployment for drift detection, compliance, and all the things it's really good at. But this is and having been in this space and struggled with, it's great that we have a tagging scheme, but how do you enforce it? This is something I'm really excited about. So, hey, Josh, I just want to kind of pause here, and I know and actually I should say, we learned about OPA through our work with Fugue, but you guys, or you as in Fugue, you guys use OPA. Can you kind of talk a little bit more about it?
Sure thing. Thanks. So Fugue has a long history of innovation in policy as code. We actually have some pretty fundamental patents on policy as code. And one of the things, so we've been working in this area for years, but one of the things we're really excited about with OPA, Open Policy Agent, is it has now been adopted by the Cloud Native Computing Foundation, who are the folks who maintain Kubernetes. And the beautiful thing about this is, prior to OPA, there really wasn't any high quality open way to write policy as code. You had to learn a proprietary language like in Sentinel, or a derivative of SQL like in some of the other, a proprietary derivative of SQL. So we love OPA because it's one way to write policies, and it's going to work not just across things like source code, but Fugue, I believe we run more OPA policy checks probably than anyone else on a daily basis. We run the policies in Fugue are built using OPA, and we're big contributors to the OPA open source project. We probably are in the tens of millions a day of these OPA checks against policies for all of our great customers. So if you haven't looked at OPA, I think it would be very much worth your while to take a look at that project. And I believe I'm going to be doing a presentation at KubeCon about it as well. But Dave, I also want to comment that I'm seeing a theme here. Well, 2 themes. One is the title of the slide, right? Preventing. If you think back to the beginning, as I was describing how bad guys are doing these attacks now, the automated scanning aspect, the 7 minutes, boy, should prevention be your intention going forward. So cleaning up your orphans, looking backward, and preventing them going forward, because the risk is just so great. But the other theme I see through this is a lot of these suggestions are there to make it easy for the good guys to understand what's going on. And I think that there's a real kind of message of hope there, which is that if you just do some simple things as you build, understanding what you've built, going forward becomes much easier, and to make that very human readable, to make it very discoverable for the customer.
Yeah, I kind of made that comment. I've learned a few years ago, my memory is not what it used to be, and I have to write things down. It's this similar thought here, right? So we have, you're working across these different environments. I mean, AWS and Azure, other environments across customers and different tiers. There's so much going on. There's a real value in doing preventative work or preventative measures so that you can quickly kind of come up to speed on what is this, who's using it, what's its value, anything that, and everything we're talking about here, these are all things we use kind of in the trenches to manage environments. So anything that we can do to make our job ultimately faster, safer, cost our customers less, cost us less, less stress on us. These are things that we found to be valuable in managing environments. So, yeah, it's what is an ounce of prevention is a pound of something. It's a little bit of upfront work. Will definitely help you in the end. All right. Yeah, let's go to the next slide. Yeah. Okay, a few more thoughts on prevention. Well, the first is how are you deploying things? If you aren't using infrastructure as code, that's probably the number one thing I think any environment can do in efficiently managing their public cloud environment. Pushing buttons in a console, like you deploy an EC2 through the AWS console, right? It's going to deploy a bunch of other stuff behind the scenes because it knows what you're trying to do, but you don't have visibility into that. And then when you go and delete that EC2 or that VM, those supporting resources, they aren't cascaded out in deletes. So by committing to infrastructure as code, so that's CloudFormation and AWS, that's Azure ARM templates, that's like a Terraform in a multi-cloud environment. It does a bunch of things. It's going to help you across the board. But germane to this topic is you have to declare what it is you're trying to deploy. And it's not going to automatically create the supporting resources. So just by dint of doing this, you're going to know more about what's being deployed. But really where the value is that when you go to destroy, that's a Terraform term, or remove stacks or delete them, it's going to much more thoroughly remove what it is you've deployed than using the Azure portal or using the AWS console. And another piece to this is just be aware, and I've kind of mentioned it, excuse me, that whether you're using, and when I say console here, what I mean is the AWS console, and similar to the Azure portal, right? So the web GUIs, the web UIs, they work different than Terraform works. They work different than CloudFormation. Right? So rollbacks, failed deployments behave differently. Deletions behave differently. Understand how those work, because you really have to understand how you properly and thoroughly remove resources you no longer need as broadly as possible, so you don't end up creating that sort of orphanage environment. Drift detection, and this is obviously an area where Fugue is fantastic, is keeping track of what's being deployed is really important to understanding what ultimately needs to be removed. So we have config set up so that each night I get an email of a summary change of each account, assuming something's changed. So it's a quick read and a quick way of understanding, hey, this developer deployed this stack was deployed, these resources are deployed, so that I can create a mental check on going, okay, I need to keep thinking about that. I need to talk to the developer about what they deployed, make sure there's an end life cycle to it. So drift detection, which is really fundamentally a configuration management and a compliance piece, is also important and extremely useful in understanding what's been deployed. Because if you have dev environments where they're more open, and you need self-provisioning for developers, and you want to really realize the value of that public cloud, the speed, right, self-provisioning. There's, other than this sort of iterative or incremental notification of what's changed, it's hard to keep track of what people are doing and what's been deployed. All right, and the last thing is, this really probably is the most important thing. It's not the cool, it's not a cool screen or a script or something, but really, I think the most important thing you can do is to commit to recurring, routine auditing and reporting of your environments, and use the tools. Hopefully some of the things we've shown here are of some value, hopefully. You'll have to figure some out on your own and do your own, some investigation. Quarterly 2-hour meeting with your engineers to do a deep dive on what's out there, or maybe part of your monthly billing process when you're paying your invoices is to sit down and do an audit of what's in that, and use that as a roadmap to investigate what's out there and what can be removed. You will save money. I mean, every account I've ever been in since my first exposure to AWS in like '08, every environment, you can remove stuff that's not needed. You will save money for your customers or yourself, and you'll reduce your threat surface area. And then here are some things that we get really excited about and like working with our customers on, is moving towards that immutable and ephemeral infrastructure model. Blue-green deployments, align infrastructure lifecycle to your sprints or releases. In other words, let's have environments that last hours or weeks, right? Not years, right? Let's have that. That's the and in order to realize this, you have to script and automate. But by doing that, you're ensuring that you keep track of what's out there and you're removing it in a routine fashion. All right. Yeah, and the last one is, I think, tough for organizations, but it's important, is that onboarding and offboarding process, cleaning up directories and identities, keeping no longer needed users, keeping them out. So, all right, I'm going to stop here, maybe toss it to Josh or Drew, and we'll close this out. I just want to say thank you, everyone, for your time. It's been a lot of fun, and hopefully we can do this again.
Great. Yeah. Dave, why don't you go to that last slide? Oh, sorry, Drew, go ahead.
Nope, I was just going to move to Q&A. Yeah, great. So if we don't get to your question, we will reach out to you directly with a response. So we got a handful here. Let's go. I think you touched on this, Dave, so why don't we send this to you. Can you talk a little bit more about the security of dev environments? Because we focus on production when it comes to security, and we haven't really thought about the dev environments.
I think, a few thoughts are, and I kind of mentioned it a slide or two ago, is people go to the public cloud, the AWS and Azure and other environments, because they expect and want the value of speed and of the flexibility, elasticity, self-provisioning. Well, in dev environments, you really need to support that. I think, I want to be as out of the way for my developers as possible. I want to be as sort of allow them the most unfettered, unencumbered experience. In doing so, you're going to inherently introduce more risk. You're going to sort of inherently have a more fluid, dynamic environment. And in that case, I think we can make an argument that you're more prone to open and expose vulnerabilities. So, we think about applying these best practices and tools to production environments where they're very sort of buttoned down and stable, and that's really important. It is production, but we know there's risk. There's data risk. Test data management is a huge challenge to a lot of environments, especially larger customers. So we need to balance that flexibility and access with security. And I think what it actually does is probably makes the security risk harder to challenge and potentially more important for these dev environments. Otherwise, you lock them down and you squeeze the value out of it, and then you're really no longer getting the promised value of why you've gone to AWS. So,
yeah, I'd like to chime in on that briefly too. Sure. This was a kind of a constant thorn in my side. I'm a developer at heart, and developers need the ability to go fast, as you're saying, Dave. I mean, that's the reason cloud is so awesome and why people can do their digital transformations and roll out new services. But developers were not being given tooling to understand the security posture of what they were making. And so Fugue, we like to say we're cloud security for engineers by engineers, right? It's designed to fit in your development cycle. So in the same way you might get a compiler error telling you you've got a miscast type, you can get feedback in the CI/CD pipeline, just like you guys are doing at New Light, that says you're not allowed to have that port open. And I think by doing that, we could actually get to a higher state of security than we've ever seen around these things, because that just wasn't possible in the data center. It was just a trust relationship with security and ops.
Yeah, and so this one actually is kind of a follow-up to that or related. What are the ways that we can get developers to do a better job of keeping their environments clean of orphaned resources, or are there tools that we can provide to them to do a better job on that?
Yeah, this is
Yeah.
Dave. Go ahead, Josh.
Uh, e- Either way, you go first, man.
Yeah, well, a few thoughts are is um, when you're building deployment processes and models, keep developers in mind. So, whatever tools they're using and are used to, and are going to be using for the development. This has worked for one customer, is developing. And for that customer, it was Azure ARM templates that developers can use in order to deploy their environment. So we want them to use infrastructure as code. We want them to get away from the portal or the web-based deployment. But they're writing in that case like .NET code. So what we did is we created a library of Azure ARM templates that they can drop into their IDE and use. And so we're giving them sort of an easy on-ramp into the infrastructure as code model. That worked pretty well for them. What are your thoughts, Josh?
One, I totally support that notion. Giving the developers tooling. A lot of people who aren't developers don't have a kind of distorted view of what developers do. As somebody who's been writing software since the 80s, developers, in my experience, primarily do a couple of things. One, they look for examples when they're trying to solve a problem they haven't solved before. They will copy as much code as is safe and legal to do so that they don't have to write it when they find those examples. So what you're doing, Dave, there is you're giving them those examples, and they want that, right? Developers don't typically want to start with a blank screen. They want to solve the business problem. So, and there's nothing pejorative in that description. You should want your developers writing less lines of plumbing code and devoting their time to writing business logic that moves your company forward. So that's a great approach with providing them those templates. But I would add another aspect to this, which is I think a lot of folks who aren't developers think developers sit down and stare at the night sky and mentally build the complete picture of what they're going to write code to do, and then sit down and write the code and have a system. That's really not how it works. It's really highly experimental and iterative. So when you sit down as a developer to build something, you're trying stuff, and your tools tell you if it's going to work or not. That's how programming works, right? I mentioned earlier, the compiler will tell you if you've got a type mismatch, if you're using a type language, et cetera. So I think fitting into that way of working, where whether the developer's using infrastructure as code or, heaven forbid, going to the console, we all do it sometimes, especially learning new services, having that feedback loop that doesn't require a security audit team to roll in and point at things and scold them publicly, but instead they can look and see along the way, oh, that's actually not okay to do from a security perspective, is also critically important if you want your developers to embrace making sure they're doing things the right way.
Great. Why don't probably both of you could address this. I'll send it over to Dave first. What about Azure? Are there any kind of differences, or is this problem similar on Azure as it is on AWS?
Yeah, so I mean, fundamentally, it's the same challenge. The primary resources are the same. There's a Microsoft page you can search, and it gives you like a mapping and analogy. If you know AWS, an EC, it's called an EC2 here. It's called a VM. The fundamental pieces of the blocking and tackling of how these environments work is extremely the same. Very similar. So I'm sure one environment does one thing better or different, and sort of off to the edge. But fundamentally, there's no real difference. There's nothing. I mean, maybe the resource group thing, because that's required in the Azure environment, that might be a benefit to clean up. But fundamentally, the challenge is the same. The challenge, the cost additions, the security issues, it's really the same. So I'll stop saying it's the same. I probably said it 16 times in my answer.
Okay, great. Well, why don't we go ahead and wrap up? Thank you, Dave, for joining us. This was a super fun webinar, and I learned a lot. You can reach Dave. His email address is up there on the screen. I know New Light does some really forward-thinking work on AWS and Azure, particularly when it comes to keeping things secure. With Fugue, you can give Fugue a try for free at fugue.co/go. It takes about 10 minutes to kind of get it set up, pointed at your environment, and fully visualize everything that you have running. And validated against a number of different compliance regimes. Other than that, I appreciate all of your time. Thank you and take care.
Yeah, thanks everybody. Bye-bye.
Thanks.